Welcome to the Microsoft Australia OEM Team webinar for December 2016. In this recording, I'll cover the content that we went through at the customer and partner section in the morning of the recent Windows Server launch roadshow, just so you can get an idea of what topics were covered just in case you weren't in attendance. Now, to highlight where this is different from the previous month's recording, this was really around the OEM and System Builder session content that was focused really on the OEM related things that you need to be aware of. This is more of a general view of what's important to customers. So this one starts stepping outside of only working with standard, starting to look at how we work with some of the data center capabilities, and then also some of the hybrid cloud integration things to think about as well for this. So this recording should go for about an hour today. So thank you for joining, and hopefully you get something out of this.
Welcome to the Windows Server 2016 and Hybrid Cloud Roadshow launch content. This recording series is focused on some of the changes that have occurred with Windows Server over the several generations that it's been around. So roughly it's been around for over 20 years now, but it's really been 20 years since the first major release in terms of market acceptance and customer utilization, which was Windows NT Server 4. And this was really what was classed as a server for the masses. So it was something that was easy to deploy, easy to manage, and it really started getting wide-scale adoption during that period. As we moved through to the Windows Server 2000 timeframe, this was really a huge change for Windows Server. So it moved across to leveraging technologies like Active Directory. So pieces like group policy, etc., really made it a much more enterprise-ready operating system. So it was something that was able to scale up to much larger organizations and really started to embrace quite a few additional technologies that were very useful in larger organizations. With Server 2008, this was really when Windows Server really started to enter into that all-important data center market. So the ability to leverage large-scale deployments, the ability to scale up, the ability to scale out, support for large numbers of servers in a particular cluster, for example, were important parts of this conversation during the Windows Server 2008 era. And then we also had the Windows Server 2012 launch, which was really the first version of Windows Server which had an eye towards the cloud. So whether we were talking about hybrid cloud, whether we're talking about public cloud, whether we're talking about private cloud solutions, Windows Server 2012 was really where we started seeing some of the basis for some of the technologies that we're introducing at the moment with Windows Server 2016. Now, obviously, alongside this, we've had evolutions in cloud technology taking place, as well as the increasing importance of management solutions like Configuration Manager, Virtual Machine Manager, etc., components of the System Center suite, also growing in importance in terms of the capabilities and the savings that they can provide to large organizations. Now with Windows Server 2016, this is really the first time that there's been very tight integration between Windows Server and services from the Azure platform. So obviously this is a move that, looking forward, is something that's very critical to Microsoft. And over the course of this series of recordings, you'll find that we start exploring some of these in terms of how Windows Server gives to the Azure platform and how Azure also gives to the Windows Server platform, and how System Center is still going to be that first choice of management when you are looking at how you do management and deployment, whether from an on-prem perspective or whether you are looking at hybrid cloud scenarios. Taking a look at customer IT concerns, well, some of the concerns that we see here, we get questions around security, we get people wondering how can they start taking advantage of public cloud capabilities. So how can you leverage your current platforms, extending those out into cloud environments to leverage some of the benefits of cloud platforms, such as the agility and some of the different capabilities that it provides you. How can you pick and choose how you can integrate them? So is it easy to migrate workloads from one to the other? If you move it to the cloud, what are the chances you can move it back on-prem? These are important conversations that are had between Microsoft and their customers on a very regular basis. Another thing that cloud services have really started to highlight, though, is just how much shadow IT is taking place inside of organizations. So it might just be a small team of people using a certain document sharing solution versus using the corporate solution, but as you go through most organizations, you'll find that there are a lot of cloud solutions, software as a service type offerings being used that may not necessarily be part of what the organization's official guidelines do endorse. Now, finally, a lot of organizations are worried about should they be concerned about the direction that they're moving into. So if they are investing in one area, is it an area that's really worth investing in? So sometimes these aren't going to be easy answers to questions, easy questions to answer. At other times, though, they will be pretty simple to have some grounding conversations that we can then move forward with to start planning out the next generation of solutions. So some of the things that we do here time and time again is that, first of all, hybrid cloud is really a big important part of this conversation. So people aren't willing to throw away what they've invested in over the years, but they do want to start leveraging these cloud technologies. So cloud technologies are very strategic. Now, over the last few years, I guess the big shift that we've seen in a lot of ways has been instead of people talking about moving to the cloud, people are talking about moving to a hybrid cloud scenario. So once again, just picking up on the best of both worlds. And then other things we hear people saying, well, really hybrid's the only option. We're too big an organization to move everything to the cloud. And, but the cloud still offers a lot of additional flexibility versus some of the things that we can do on premises today. So how do we approach straddling two worlds? So how do we take a look at this hybrid model? So if we take a look at the traditional model, well, we're completely responsible for everything from our own internal infrastructure, our own servers. We've got to go through and keep building out infrastructure over time. And for a lot of organizations, this has meant that in some cases they've been focused on building out solutions that have from an organizational perspective, meant that the organization has had to start getting into other areas that they weren't planning on getting into, such as, data center management, with concerns around cooling, power, networking, etc. So as we start moving across to a cloud model, some of the things that we can start doing there is saying, well, let's take a look at how we can leverage microservices. How can we start just, deploying things out in on hardware platforms that with several layers abstracted from those platforms, so that we can still spin up virtual machines and workloads the same way we've done on-prem, if not even in easier and more flexible approaches. And the other thing with cloud models is that it starts embracing these new types of approaches, such as being able to leverage things like DevOps functionality and being able to go through the process of standardizing configurations, standardizing on the different processes that are deployed. So how can we start taking a lot of those learnings we've made over the years and effectively start turning them into templates that we can start rolling out very, very quickly as we move forward? As we take a look at the three primary IT stress points, the first being security threats, which we'll focus on shortly, is really taking into account some of the major changes that are occurring in both the protection of resources that are becoming more vulnerable in many ways with some of the existing technologies that are in place, and how we can start addressing some of those concerns as we move forward. For data center efficiency, the following module will talk about some of the changes around software-defined compute, software-defined storage, as well as software-defined networking, and what Windows Server 2016 really brings to the table there, and how System Center can start enhancing that. And then finally, supporting innovation is where we start focusing on some of the new capabilities, such as the Windows Server containers, the Hyper-V containers, as well as starting to talk about technology such as the new Nano Server. So when we really want to start looking at high-density workloads with minimal overhead, that's really where we can start looking at some of the new technologies there. So as we start taking a look at security, for all organizations, security is a top IT priority. In the past, there may have been a security team within an organization, but now security, it might be something that specialized teams do focus on, but it also has to be first and foremost in the minds of pretty much all types of employees. So we're not just talking about IT staff, we're also talking about users, we're talking about the CXO level individuals in an organization as well. So why is it so critical? Well, we're at the point now where globally, it really is a massive industry in terms of trying to protect our IT assets. So if we take a look at some of the things such as the impact of lost productivity and growth being pegged at $3 trillion, the average cost of a data breach being listed here as $4 million, and $500 million being listed as an amount that might be required for corporate liability coverage. These are all things that have gone beyond, just the risk of a data leak, for example, to all of a sudden becoming things that can really impact an organization at many layers, whether it's in terms of lost productivity, whether it's in terms of lost customer trust. There are many different ways that this can start affecting organizations. And we're at the point now where the scale of these types of attacks is becoming much larger than it's ever been in the past. When we take a look at the attack timeline for many types of common attacks, the first thing that takes place is attackers will find any type of weakness they can inside an organization. So how can they either compromise a user? How can they compromise a device? How can they compromise a service so that they can go through and really get that first level of access inside the network? Now, in the past, a lot of this may have been based around trying to get through the firewall and get access to things inside the network. But today, in a lot more cases, it's really about trying to compromise a user or a device more simply by just getting them to click on a link. So things like phishing, social engineering attacks, they're the way that malware tends to spread to start getting these types of attacks going in an organization. Now, normally within 24 to 48 hours, domain admin credentials are compromised. Now, while that is scary, what's really scary is that on average it's around 200 days until the attacker is actually detected, because during that time period they're not doing anything, or they're trying not to do anything that triggers any kind of internal intrusion detection systems, for example. So they're not really trying to push out large amounts of data. Instead, they're just carefully trying to go around the network, trying to launch different types of attacks. So basically looking at things like pass the hash, pass the ticket, and other types of ways that they can gain additional credentials inside the organization. And then once it's discovered, really it can be quite a lengthy and complicated process to try to work backwards to figure out when did that attack actually take place. So the three ways that we start looking at how we approach this with Windows Server 2016 really focuses on protecting the identity. So how can we make sure that things like pass the hash and pass the ticket attacks become much more difficult? How can we protect operating systems regardless of whether they're on-prem or in the cloud? And then also, how can we secure virtual machines? So let's jump in and take a look at some of these. So first up, for challenges in protecting credentials. As I mentioned, things like social engineering are often used to go through and can lead to credential theft. And most of the time, the attacker may not necessarily target people with admin credentials, but within a short time period, that's really what they're going after because they know they're much more valuable. So in this case, once Ben is compromised, additional accounts can be compromised from there until we get to the point that we do have the appropriate level of admin control. Now, the problem that we've got in organizations today is that for the typical administrator or someone who's part of an admin group, they may be part of the domain admins group, for example, hopefully not part of enterprise admins, but what normally happens is that person is part of that group all of the time, rather than it just being an alternate identity that they sign in as. So if someone does compromise their credentials in some form, all of a sudden that person has now got full access to all of the capabilities of that user's admin capabilities for pretty much 24 hours a day, 7 days a week, which really is far from being perfect. So when we start taking a look at the way we can start protecting against these types of attacks, this is where we can start leveraging several different technologies in Windows Server 2016. The first of these, Credential Guard. So this is where we can start doing hardware-based virtualization to actually start securing the operating system from the actual kernel of the operating system. So even if the operating system is compromised, we can't go through and start getting access to the user credentials because they are actually in another virtualized container. This is also then leveraged by Remote Credential Guard, so being able to use that same technology, but in this case with the additional benefit of remote users requiring an appropriate certificate before they can actually connect in. Now the next two, Just Enough Administration and Just-in-Time Administration, well, these work hand in hand so that we can say, well, Ben doesn't necessarily need to be a domain admin or an admin all of the time. and he only needs to be an admin for certain capabilities. So it could be something where it's a new employee, and what we want to do here is say, well, look, you're new to the admin team. We're not necessarily going to give you the keys to the kingdom initially, but what we'd like to do is just give you enough credentials to perform a task. So domain admin, that's kind of overkill. So let's just give you something quite specific. So is there something within DNS or DHCP, for example, something within Active Directory that you need to take control of? So we can start assigning rights that are very specific, but then we can also overlay just-in-time administration over the top of that. So once we start overlaying just-in-time administration, what this means is if we take a look at that blue, the amount of blue that we've got in that chart, all of a sudden, with just enough and just in time, all we're doing is giving people the appropriate capabilities for the time that's required. So all of a sudden, we've gone from a user being compromised, basically meaning that those admin credentials are compromised, to all of a sudden, it's only within the window. So if that person doesn't have rights, then the person who's performing the attack isn't going to be able to gain any kind of privileged rights against some of the resources that it's trying to access. So all of a sudden, we see a huge improvement there. When we take a look at challenges in protecting the OS, so whether we're talking about virtual machines as they're booting, whether we're talking about physical hardware with host operating systems being installed directly on top, we've got situations where the hardware itself doesn't necessarily have any indication that something might be compromised. So long before the operating system starts, there could actually be scenarios, and we've seen this in the past with things like rootkits, for example, where things are compromised before the operating system even starts, and the operating system doesn't see any of these threats because these threats are masking themselves. So what we can start doing now is we can start leveraging some of the new technologies that are available in server environments. So we'll talk about these as we go through the next few slides, so that we can start basically saying, well, is this machine in a good state and ready for us to start the operating system? And if not, do we need to shut it down? Do we need to put it into isolation? Do we need to put it into quarantine, for example? So let's take a look at how these work. So we've got a variety of technologies here. So first up, we've got device guard, so that we can make sure that only permitted executables can run. So we're effectively starting to provide a more comprehensive whitelist type approach. We've got Windows Defender, which is, it's not compulsory that you have to run Defender, but at least knowing that with a new Windows Server installation, that you've got some kind of anti-malware solution installed out of the box, and it gives you capabilities such as early load anti-malware detection, for example. So making sure that drivers aren't being replaced, etc., from the last time the operating system booted. We've also got Control Flow Guard, and its purpose is to go through and protect you against unknown types of vulnerabilities, especially when you start taking a look at different types of memory corruption attacks. When we take a look at challenges protecting virtual machines, well, really the big issue that we've got here is that the virtual machines themselves are easy to modify and copy. So if I've got access to the location where virtual machines are being stored, for example, so the actual VHD files, for example, if we're talking about a Hyper-V environment, if I've got the ability to copy those files out to another storage device, so out to an external USB drive, for example, well, once I've got those, I can mount them, and I can really start, looking at them. I can attach configuration files so I can fire them up and actually see what's in them, and start doing brute force attacks, for example, if I need to go through and try to sign in to get access to more things versus just going through and navigating the file structure. So some of the technologies that have come in to help protect these virtual machines, well, first up, we've got shielded virtual machines. So with shielded virtual machines, we can go through, we can start using technologies like BitLocker to encrypt the disk, and we can make sure that by assigning things like virtual TPMs to the virtual machines, that when the virtual machines are starting, they're actually verifying that they're in an environment that they're actually safe to run in. We've also got the host guardian service. So if we need to start moving virtual machines that are, or the shielded virtual machines from one server to another, how can we move that easily without a huge amount of administrative intervention? And that's where we can start leveraging the host guardian service. So with the host guardian service, effectively the virtual machines need to actually, verify that they can run in the environment that they're actually running on. And we'll spend a few minutes talking about host guardian service in just a moment. So in order to start leveraging these capabilities, you need to be using Generation 2 VMs, which a lot of Windows Server 2012 R2 and Hyper-V Server 2012 R2 customers are already doing. But then we need to start leveraging things like the TPM capabilities so that we can then start enabling things like BitLocker, for example. Now, if we take a look at what rights are usually assigned and what are normally required, what we normally find is that if we take a look at the physical access, normally physical access is controlled pretty well inside of most mid to large size organizations. So people aren't going to get access to physical hardware, for example, the server room, the data center, unless they really they really do need those rights. However, once we start talking about the actual infrastructure or the virtual infrastructure, all of a sudden a lot more people have got rights to things than probably really need to. So if we take a look at the middle column here, we've got the Hyper-V virtual machine running, and everyone from the server administrator all the way down to the virtual machine have got rights, when in fact, we may really be thinking, well, really only the virtual machine should know what's going on here. Once we start moving across to shielded virtual machines running on top of Hyper-V, this is where we can go through and really start locking everything down, so that unless you are so unless you really have the appropriate rights, you can't do anything here. So in some cases, you might even set this up so that when you do set up the shielded or the host guardian service, some of the recommendations here are to set up a separate domain and then set up a trust with that domain, so that you can actually go through and have the fabric managed completely separate from the rest of the virtual machine infrastructure, for example. So if we take a look at some of the hardware requirements of shielded virtual machines, the important takeaway here is that with shielded VMs, we're talking about, in a lot of cases, it's not something that's designed to run with hardware that you may have already had for a few years. So in most cases, these are things that you really need to start thinking about when you are deploying new servers. It's in a lot of cases, they're not things where you can really repurpose old servers, because they're not going to necessarily have all of these hardware capabilities. So some of the things such as the SLAT and the VTX requirements are effectively enabling additional types of security and isolation when we do start looking at using virtualization. But as I mentioned, things like TPM v2 and this one, along with the next two, fall into the category of optional, but really recommended. If you're going down the path of starting to set up shielded VMs and the host guardian service, having a physical TPM, VTD extensions on your CPUs, as well as UEFI 231, really it's a good idea to sort of have those as that starting point, so that you know that when you are investing the time and effort in getting the host guardian service running, that you can leverage that. Moving on to the next section, transforming the data center efficiency. So when we talk to IT departments, some of the questions we hear about, some of the comments we receive are things such as, being able to do more with less, having more demands coming from other parts of the business. So where are the different types of reports, with things like compliance becoming very important? The CEOs are obviously expecting security to be given very, very high priority. The idea of some kind of breach that gets public attention is far from what they desire. And they also need to make sure that you can keep ahead of the competition. So from the developer perspective, they're looking at some of the new methods such as DevOps, for example, for starting to be able to roll out new applications and new services very quickly without some of the barriers to rolling things out that they may have had in the past. So how can we start addressing these? So with data center efficiency, really the three main categories we're looking at here are software-defined compute or enterprise-class virtualization via Hyper-V, software-defined storage. So what are some of the enhancements that we've got with storage spaces and storage spaces direct? And then software-defined networking. So this is really where we start taking a look at some of the pieces that have been brought down from Azure, for example, down to Windows Server. So first up, from a scalability perspective, even though most customers don't really bump into these types of limits, such as 4 terabytes of physical memory per server, 320 logical processors per server, a terabyte of memory per virtual machine, or 64 virtual processors per virtual machine, which were the limits that 2012 and 2012 R2 had. Due to the demand from large hosting providers, the Windows Server team had to go through and start supporting, larger degrees of scalability scalability here. So up to 24 terabytes of memory per physical server, up to 512 logical processors per server, a huge jump from 1 terabyte of memory per virtual machine up to 12 terabytes per virtual machine, as well as up to 240 virtual processors per virtual machine. Now, to give you an idea of really one of the big driving customers behind this for the Windows Server team was actually the Azure team, because as you can imagine, anything they can do to improve server density, for example, is really going to help them from a performance perspective. And even though we may not be looking at this level of hardware for our own on-prem deployments, any of us who are looking to use Azure services, for example, will benefit from some of the cost savings that these kind of capabilities will start providing to the Azure team. So let's start off with a conversation around some of the enhancements to clustering. So first up, we've got the Cluster OS rolling upgrade, where we can start draining the virtual machines off existing Windows Server 2012 R2 cluster hosts. And then once they're all drained off, we can shut that server down. We can do an installation of Windows Server 2016 onto that server. We can join it back into the cluster, make sure the settings are appropriate, and then getting it to participate alongside those other 2012 R2 servers. Now, while it's running alongside those, it's in what's called mixed OS cluster mode. So as soon as we're in that mode, we can then continue to keep migrating more of the workload over to Server 2016 hosts. And then once we get to the point where we're more than happy with the 2016 support from our software vendors, our hardware vendors, for example, then we can then make the switch and say we just want to start using the Windows Server 2016 native mode in that case. Other enhancements that we see here are things like virtual machine resiliency. So making sure that as virtual machines start leveraging things like cloud storage in more and more, as they start using shared storage in more and more scenarios, making sure that just small interruptions to the network or to storage, things that might take a little bit of time to troubleshoot sometimes, just being able to build in a little bit more resiliency to that, so that instead of the virtual machine just freezing or an entire bank of virtual machines freezing, knowing that it can sort of freeze temporarily. So instead of freezing, it will just start queuing up the I/O, and then as soon as the storage is back online, it will start writing everything out as required. Now, the other thing that we've got included here are the fault domain aware clusters. So this is where we can start taking a look at things like the failover behavior. So where should the failover VM start? So if we're looking at scenarios like stretched clusters, for example, if we're starting to use some of the technologies we'll talk about next, which is things like the replica capabilities with storage, making sure that the virtual machines are starting up in the appropriate data center based on some of the policies that we start providing. So continuing on with storage replica. With storage replica, the conversation there is really around, how do we want to replicate data from one Windows Server storage environment to another? So do we want to do it synchronously? Do we want to do it asynchronously? So if we want to do it synchronously, the important things to understand is that the general recommendations are that you've got less than 5 millisecond latency between the two locations that you want to do the replication between, and that you've also got gigabit connectivity between those. Now, as soon as you start looking at async synchronization, all of a sudden those requirements get dropped quite dramatically. So in a lot of cases, if people, there might be, that you might desire synchronous capabilities, but all of a sudden, these are things that Windows Server Data Center has just got included as part of the base storage cost. Now, with storage quality of service, this is where we can start setting quality of service policies on storage, so that if we are going to be migrating to new virtualization hosts, for example, or to new storage scenarios using Windows Server, by putting the quality of service like minimum, maximum type IOP requirements in right from the beginning, it means that initial users aren't going to take advantage of everything that the platform has got, which means that over time, as more and more workloads are migrated to that, those initial users aren't going to see reductions in performance, because instead we've built out a solution that's designed to cope with what we require. If you compare this to some of the situations that you may have encountered today with storage, where you migrate certain workloads over to the new storage, and initially the users who were migrated first absolutely love it. The performance is better. It's a night and day difference for them. But then over the coming weeks or months, as more and more of the workloads are moved over, as some of the old storage solutions are retired, all of a sudden those users start noticing that things are slowing down, and they start questioning, well, we spent all this money on storage, but we're not really seeing any benefits. So by implementing storage quality of service, we can give a much more consistent experience over the life cycle of the different workloads as we deploy them. Now, the final piece on here, Storage Spaces Direct. This is where we can really start doing some interesting things with Windows Server and storage spaces. But in this case, instead of thinking about storage spaces as something that's shared storage that we can scale out using things like JBOD, for example, just using standard highly affordable drives, all of a sudden we can start adding in things not just like SAS SATA drives and SAS and SATA drives for mass storage like our 7200 RPM drives, for example, or high performance such as through SATA or SAS SSDs. All of a sudden we can also start taking advantage of things such as NVMe drives. So all of a sudden we're talking about going from hundreds to thousands to tens of thousands and more IOPS per second. So for workloads that are IOPS intensive, all of a sudden we can really start getting huge amounts of performance. So let's take a closer look at Storage Spaces Direct. So first up, we can keep using Storage Spaces Direct the same way that we do today. So we can have our Hyper-V hosts, for example, sitting out there, so we can have our Hyper-V hosts being something that we can scale out independently from our storage solutions. But then when we start taking a look at the hyperconverged solution, all of a sudden this is where we start saying, well, you can support running your Hyper-V hosts on top of the same hardware that your scale-out file server is running on top of. So using Storage Spaces Direct and having high-speed connectivity between the servers. So in this case, when we talk about high-speed connectivity, even those solutions like 10 gig, 40 gig, and 100 gig Ethernet, for example, might be able to meet your bandwidth requirements, you need to take into consideration what the CPU load of those is going to be. Whereas if you start looking at networking technologies like RDMA, all of a sudden you can get very, very high throughput. So, we're talking 40 gig with, higher speed cards such as 56 gig, as well as higher speeds also in testing, but without any of that CPU impact. So all of a sudden we can keep scaling. And for the hyperconverged solutions, you have to approach the architecture a little bit differently there. Microsoft is building out a Storage Spaces Direct logo program, so you can get an understanding of what's really required. So this also falls into that category of not necessarily going to, work well on lower spec hardware that's older. This is something that is going to require, more processing power. It's going to require lots of cores, but it scales out to 16 servers at the moment. So keep an eye out. There will be a hardware compatibility list specifically targeting storage spaces solutions, so you can get an idea of some of the types of things you can do with that moving forward. Now, the final piece of this section is the Azure-inspired software-defined networking. So anyone who's already done some work with technologies inside of Azure, especially in Azure Resource Manager with the virtual networking, a lot of the types of things you can start taking advantage of inside of this Windows Server 2016 software-defined networking will be very, very familiar to you. So being able to set up specialized virtual appliances, being able to set up network security groups to control traffic flow in and out of network segments or between different virtual machines, for example, setting up a distributed firewall. So with that firewall, for example, being able to say, well, how do we want to distribute this? Are we targeting physical network adapters? Are we targeting virtual network adapters? Do we really just not differentiate between one or the other? And these are the types of things that we can really start doing with this new network controller that we can put in place. So this means that we can start reducing costs. We can start treating, in the past where we would have sort of thought about, well, a few years back we would have set up the management network, we would have set up the storage network, we would have set up the end user traffic network. We can start looking at converging a lot of that traffic because now we've got some of these really high speed solutions, including RDMA. So all we really need to think about there is, what quality of service policies do we want to put in place to make sure that we can really take advantage of all of that bandwidth without impacting any one particular workload. So there are a lot of changes that we've seen here. So let's now move on and talk about the next piece of the story, which is taking a look at some of the new technologies that have come into Windows Server. The third pillar in creating opportunity for growth is really around supporting innovation. So if we think about what innovation involves, well, we're at the point now where cloud native apps are really required across all types of industries. So industries that in the past may not have necessarily viewed themselves as bleeding edge, for example, are suddenly having to really start to adopt a lot of new technologies at a rapid pace based on the requirements of different types of users and different competitors starting to enter the marketplace. So some of the ones that are listed here: travel, transportation, healthcare, banking, entertainment, retail. To list them, it doesn't really, pay tribute to what's really going on, which is that every industry really needs to be thinking about how they stay relevant, or at least the players in each industry need to start thinking about how they stay relevant in this case. So when we start taking a look at the three main areas inside of app innovation with Windows Server, the first one is running existing apps with more security. So how can we take our existing apps and run them in new models that make more sense than some of the models we may have looked at previously? How can we continue to evolve these existing apps? And then finally, what are some ways that we can really start creating innovative cloud apps, cloud native apps, but start really deploying at a much more rapid pace than we've done before? So looking at application evolution, well, anyone who lived through the 90s in the world of IT, would have seen the transition from, single machine solutions where everything ran on one box, so the database, the line of business code, the logic, etc. Then we went to two-tier applications, and we went to three-tier applications. Then just the generic term multi-tiered applications started being used. But during those time periods, one of the common things that was, normally, made things easier for people who were doing the development was they generally had a good idea of what the client was that was going to be connecting into them, because they would specifically target certain client platforms for their apps. Whereas now when we take a look at this new world of cloud native apps and microservices, these things, we've got containerized apps, we've got IaaS solutions being leveraged, we've got PaaS solutions being leveraged, we've got things that can scale up and scale down on demand. Well, one of the other big changes here with cloud native is that we don't really necessarily know what type of clients are going to be connecting into them. So we need to make sure that it's very easy not just to build out the back-end solutions, but that it's very easy to access different client development solutions for building things like from scalable websites all the way out to custom apps targeting specific mobile platforms. So one of the things that Microsoft's doing with Windows Server 2016 is looking at the world of containers and applying logic there in terms of what are some of the things that are good about containers, but what are some of the areas that need improvement. And if we take a look at what a lot of people use as containers at the moment, which is virtual machines, so effectively we're talking about hardware virtualization, well, we've got some great benefits with hardware virtualization. We've got security, each of those VMs is isolated. We've also got the ability to run completely different operating systems on each of those VMs, or different versions of the same apps across those different VMs. So they all run completely independently of each other. Now, there is a downside to this in terms of the amount of memory that's required, the amount of storage that's required, the CPU requirements of that additional overhead of having all of these layers duplicated on top of a virtualization platform. But when we take a look at containers, all of a sudden we can say, well, instead of going through and virtualizing at the hardware level, can we actually virtualize at the operating system level? So in this case, we've got the kernel, we've got the applications, but we can then start running the containers on top of that kernel. So that means that we can have a shared kernel where we can start making sure that we can get really high density, we can get very, very high performance from those containers, and we can roll out new versions very, very quickly without having to worry about what's going on under the covers. Now, there is a downside to containers this way, in that for some organizations, the idea of running on top of shared kernels may not be the best model for them. They might be thinking, what if somebody in one container does something that affects the kernel to a degree that it might start impacting the others in terms of any specific requirements they might have. So Microsoft will still give you the option of running containers, and they'll provide Windows Server containers. So you get maximum speed and density on top of that shared kernel. So in some organizations, this might be the way that they run internal workloads. When they, from a dev test perspective, it means you can really get high density here. But for organizations that really want to focus on, getting more density than virtual machines provide, they can start looking at Hyper-V containers. And what they provide is that isolation that we were used to from a virtualization platform, but it's also now running at we've got a much smaller kernel running there, but we're still getting that same level of, we're getting a greater level of performance, but we're still getting that great isolation. Now, from a developer perspective, the developers don't really have to think about when they're building containers, do they have to target a Hyper-V container or a Windows Server container. They just build the Windows container image, and then effectively it's a runtime decision. And from the IT perspective, you can use whatever management tools you want. So you can use Docker or PowerShell, for example, to go through and do that management. But if we take a look at the life cycle for containers and in terms of how does this start impacting organizations looking at implementing DevOps or who've already gone down the DevOps path, well, developers can go through and start building and testing and updating the apps. And once they've got it to a point where it's satisfactory, they can push those into the central repository. And then from there, whether it's a manual process or whether there are automation tools in place, we can go through and then roll those out onto physical machines, to virtual servers, and we can then start seeing, well, first of all, is it successfully being deployed? If it's not being successfully deployed, how do we quickly get the developer to make some changes? Or what if over time we sort of see some patterns that we need to address? Well, this means that then the developer can go through, they can make some changes, and then they can roll out new versions of those containers, push them into the central repository, and we can go through that process. Now, the big benefit here, and the big difference here that we're talking about with containers, is that we can package up our application as well as the requirements it's got. So the application might be it might be a custom in-house application, and it might have a certain set of libraries and frameworks that are required. It might need specific updates for .NET framework, for example, that may not be part of the organization's base image. So these are the types of things that could be included in that container image and then rolled out as needed to a more generic underlying platform. So one of the platforms that Microsoft is really wanting people to consider when it comes to looking at containers is the new NanoServer platform. So this is what is being billed as just enough operating system, but what it does here is provide just a very, very lightweight Windows Server-based operating system that's got very specific deployment scenarios. So it's not a general purpose operating system. It's really only got an emergency management console. So if someone says, what's the user interface like? It's like the user interface is whatever the remote management machine is that you're actually using to manage that. And we'll talk about that in just a moment. But the idea is that we can do high density deployments. We're reducing the attack surface and the servicing requirements. And you'll see as we go through the next few slides, all of this stuff will really start coming to life. So if we take a look at security improvements, the important thing to notice here is that when we look at the light blue column versus the dark blue column, the light blue column is Windows Server Core. So this isn't full-blown Windows Server with a GUI, which would obviously be much higher. So the drivers loaded, the services running are reduced as well as the number of ports open, drops quite dramatically here, as you can see. So from a security perspective, you start thinking, hang on, there's less running, which means that there's less to patch, and less ports open means there's less that we actually have to monitor and protect as well. Now, when we take a look at resource utilization improvements, we see similar stories. The process count drops, boot I/O drops by almost 2/3. The kernel memory in use drops from 139 meg to 61 meg. So again, we really start seeing that, wow, server density or workload density can really start increasing here as well. Now for deployments, this is where we can start seeing that setup time drops from 300 seconds down to 35 seconds. So we're talking a massive drop. Disk footprint drops down to below half a gig in size. So we're talking 460 megabytes. Or if we want to virtualize that, then it creeps up to 480 megabytes if we're putting it inside of a VHD file. So you can see here that we've got absolutely massive savings in terms of disk space, in terms of the services that are running, in terms of the patching. So this really gives you an idea of some of the benefits that you'll see with NanoServer as you start deploying that. So some important things to note with Nano Server is that a lot of changes had to go on in order to actually be able to get it down to such a small size. And one of those things is that, the normal management process of using group policy, for example, no longer applies. So instead we have to use things like PowerShell. We have to use, so if we use our remote management tools. So if we're using config manager, if we're using failover cluster manager, Hyper-V manager, server manager, these are all some of the things that we need to think about when we're actually going out to deploy this. Now, the other way that you can manage this, and another important technology that's in preview right now inside of the Azure portal, are the server management tools. And those server management tools are Azure based. So basically inside the Azure portal, you set up a management gateway server, and then from that management gateway server, you can remote into those machines via PowerShell, or alternatively, you can get web-based views of a lot of the common troubleshooting or monitoring apps that you'd be using natively down on the desktop. So a tool that's been released recently has been the Nano Server Image Builder, and what this does is it allows you to go through and run a wizard to within a few minutes, go through and build your own customized Nano Server images. So to get an idea, you can create a Nano Server image from scratch, or you can create one so that you want something that can boot from a USB flash drive. And what's important to note on this slide is that if you take a look at the different capabilities or the packages that are available for Nano Server, it's a very small subset of what you'd normally have access to from a Windows Server Standard or data center installation. So you'll notice that you've got DNS, but you don't have DHCP. You don't have Active Directory, for example. So in a lot of cases, people might be looking at this going, well, Nano Server might be a great platform for me to run Hyper-V on top of, or it might be a great place for me to start running shielded VMs on top of Hyper-V. So you can see here that it's not designed to replace core. It's not designed to replace the server with a GUI installation. This is really targeting very, very specific scenarios. Now we can go through and create this, and you'll see that it will also provide you the PowerShell commandlet, so that if you do want to go through and make adjustments again without having to use the Nano Server tool, creation tool, you can go through and just cut and paste that into your PowerShell collection and keep working with it from there. So just to wrap this section up before we move on, a lot of the technologies that we've spoken about in this module, you can go through and really start simplifying the management and the deployment of these by using System Center 2016. So it's got inbuilt support for things like the shielded networks. So inbuilt support for storage spaces direct for the clustering capabilities, etc. So for a smaller organization, System Center may not necessarily be required, but for a large organization that's embracing Windows Server 2016, if they haven't already started looking at System Center 2016, it's definitely recommended they start taking a look at that to make sure that they really get a good understanding of how they can leverage some of these new technologies and really automate them all the way through the life cycle.
Now moving on to the resources for this month. Well, still really the big thing that we've got coming up is the Microsoft Australia Ignite event happening on the Gold Coast on the 14th to 17th of February. So myself and quite a few other people from Microsoft will be there to chat to you and go through technical content. And this is really a very technical focused seminar, series of seminars and sessions. If you've never been to an Ignite before, well, you may be confused as to the Ignite naming. This previously was known as the TechEd conference, but globally it's been rebranded as Ignite. So if you do get a chance to come along to that, definitely take a look at the registration page, sign up, and we look forward to seeing you there. Now, other important resources are the Microsoft Australia OEM team blog site, where I write several posts a month covering OEM-related issues around Windows Server and Windows 10 deployments. And we've also got the OEM Server pre-sale support email address. So that's oemserverau@microsoft.com. So please note, as I mentioned, this is a pre-sales only. We don't do product support on this one. So if you do contact us with a support question, we will have to refer you over to the support forums. But otherwise, if it's related to OEM server questions from a sales or licensing perspective or a product feature perspective, please contact us. Now, also, don't forget to sign into the rebranded, relaunched Microsoft Smart HQ, which has got a strong focus on Windows 10, Office, and the server products. So make sure that you sign in, take a look at what's new in there. So that brings us to the end of this month's recording. So thank you very much for joining us, and look forward to you joining us in new sessions as we approach the new year period. Thank you.